Let me start immediately. I will be there. This is the content of the second presentation. Basically, what can we say about CRMs, capacity remuneration mechanisms, when markets are integrated or are interconnected? There's always a tendency to think about CRMs as isolated markets, but electricity markets, in most of the case, almost always, they are not isolated. They are integrated, so we need to assess this. The way we'll tackle this task is to very quickly review what we have already seen in the previous presentation, and it focuses mostly on the issues related to CRMs in open markets. We will then discuss the European example, drawing mostly on work that we are doing at CER and ACER on assessing the possible ways that there could be participation of external generation in the connectors to CRMs at the European level. Very quickly, you've already seen it, so I'll be very quick, that CRMs, capacity remuneration markets, they can be classified as price-based tools, capacity payments basically, quantity-based tools where the quantity is set and the price, the market provides the price, typically strategic reserves, capacity obligations or capacity auctions, and then systems in which the option value of the capacity is explicitly marketed, typically called the reliability options. CRMs are a way to remunerate capacity, not energy, ex ante, before delivery. What's the possible justification of CRMs? First of all, when there are no CRMs, we can call the market an energy-only market, in which it's just the remuneration of energy that provides sufficient incentives to provide capacity, and therefore, because of this capacity, there will be enough security of supply. When that's not the case, when markets have an explicit remuneration of capacity, through the ways we have seen before, there are possible justifications for it, which typically called the issue of missing money, namely that there is not enough remuneration due to the price spikes to induce power producers to enter into the market. This is sometimes due to the fact that there exist price caps, or that the value of lost load, the highest possible value of energy in a market is set up below what effectively would be the value of lost load. There might not be sufficient liquidity or sufficient tools to hedge against risk, price risk in the market, or there might be power market, and there might be an extremely risk is typically induced by high volatility, and there might not be enough storage or the necessary participation that would reduce this volatility and reduce this risk. The cons are that typically the fact that CRMs can distort the market if they are not properly designed, and it's not easy to design them properly because there are a lot of complexities in it. We saw it in the previous presentations. So you can they could provide inefficiencies because some money could be wasted in the sense that it would not be dedicated to provide the level of security supply needed, or maybe because it provided too much or because it provided too less. All these, the typical analysis is set up in isolated fashion, but markets are integrated. So we need to discuss what are the issues of CRMs, introducing CRMs, when markets are integrated, in particular when markets have different CRMs or when there are markets with and without CRM. We will cover three aspects in particular: the so-called capacity leakage, or the possibility of exerting free riding between a market that has a CRM and a market that has no CRMs and a market that is integrated. We will discuss the interplay between transmission investments and generation investments. And then we will discuss the issue about security supply assessments, which is somehow a prerequisite to provide capacity, to assess whether there is a need to introduce a CRM or not, and the relationship between the security supply assessment and market integration. Very quickly, capacity leakage. What's the problem of capacity leakage? Well, it's a very simple situation in which, imagine there are two markets. One, call it market 2, in which there is a CRM introduced, and the one, market 1, in which there is no CRM. You can expect that in real time, the CRM either directly or indirectly reduce the price of energy. The reason we saw it in the previous presentation, but the reason is basically because if the CRM is properly set up, it induces a lot of more investment, and investment means that more capacity is available, and so supply is increased, price is reduced. Then it can also be done explicitly, this price setting, for instance, through a reliability option, because the strike price will tend to converge to the strike price. But in any case, in principle, you can say that the CRM will induce a reduction of energy price. You can even think it the other way around, that the reason to introduce CRM is because there was a too reduced energy price, not enough to provide incentives to implement investment needed to provide security. Assume that in market 2, so the price is reduced because of the introduction of CRM, while in market 1 that's not the case. At the time of system stress, for instance, there might be a free riding in the sense that the capacity that has been paid in market 2 is not there to provide energy in market 2, because if the two markets are linked, the energy could be exported to market 1, because at time of system stress, if there is a joint system stress, the prices in market 1 will spike more than the price in market 2. This effect somehow is basically the effect of free riding of the investment of capacity in market 2 by the market 1 that has not invested capacity. I'm not calling, again, pay attention, this does not mean that as a logical consequence there should be also capacity in market 1. This is just saying that one possible element to be taken into account is the effectiveness, and therefore the inefficiency due to the fact that it's not effective, of the CRM in market 2 when the market 2 is linked to market 1 and when there are situations of system stress. Interplay between transmission and capacity. Capacity means investment for generation, but there is also transmission. Here I have depicted and described some very simple cases. Suppose this is wholesale market. Have a look at the fact that even if you have capacity in here, this is capacity for a given time, for instance for an hour, so basically the horizontal axis is energy. But you have also depicted the existing transmission capacity between market 2 and market 1. Suppose that these are net supply of energy market 1, and this is net demand of energy market 2, and they are both with a given level of installed generation capacity. Okay. So now assume that there will be a capacity regulation mechanism introduced in market 1. Again, I'm not saying that this should be done or not be done. We can describe about the possible, sorry, I've lost the point, here it is. We could discuss about whether it would be rational to introduce a CRM in a market like market 1, which is already a net exporter of energy. But for whichever reasons, for instance, typically it could be that the perceived level of security supply that is to be implemented in market 1, for whichever reasons, because the VOLLS is higher or whatever, is higher in market 1 than in market 2, the one that is net exported, and as a consequence, there will be a CRM introduced in market 1. What would be the consequence of this when we think about interplay between capacity market and transmission, capacity generation, sorry, and transmission generation? Well, it's immediate. If assume that there was an efficiency gain, for instance, because it was efficiently planned to expand transmission capacity between market 1 and market 2 from K1 to K2. Remember, efficiency means that, we should remember what efficient means. It is not efficient to eliminate congestion rent, the congestion rent being the difference between the price of the net exporter and the price of a net demander, because there will also be cost of investments of expansion of transmission line. So the transmission line has to be expanded up to the point in which it is efficient. where is this efficiency, is at the point in which the transmission, the marginal cost of the expansion is equivalent to the remaining congestion rent. Here, for instance, it was planned to expand the capacity from K1 to K2 because K2 was the efficient level. But if at the same time in market 1 there was a decision to expand the generation capacity, or there was a decision to introduce a CRM, and because of this, generation capacity in market 1 is expanded, well, we see that some of the efficiency gain due to the expansion of transmission capacity from K1 to K2 is crowded out by the expansion of the generation capacity in market 1. It's no more efficient to expand the transmission capacity just from K1 to K2. A further adds-on capacity should be taken into account. And the reason of this inefficiency is just due to the fact that the decision of the expansion of generation capacity, CRM, and the decision of the expansion of the investment in transmission capacity from K1 to K2 has been taken in an uncoordinated way, which induces inefficiency. Why one might think that this example is a bit ad hoc, because it's quite apparent that the market 1 is the net exporter, and because of that, there should not have been an increase in generation capacity in market 1. But even the same problem arises even worse if another case we consider, for instance. Consider an introduction of capacity, CRM in market 2, the net demand one, the one that is exhibiting a net demand. So it is importer of energy, this is the installed transmission capacity, and there will be a decision of expand CRM in market 2. Still, we could have a distortion if this decision is uncoordinated with the decision of expanding transmission capacity. And this is what we see. Because the decision of expanding transmission capacity tells us you should expand transmission capacity from market 2 to market 1. Remember, from market 1 to market 2. Market 2 is the net importer. You should expand transmission capacity of this level, the pink one, from K1 to K2. Assume this is the efficient level. But if at the same time a CRM is introduced in market 2, and because of the introduction of CRM in market 2, the net demand of energy in market 2 is reduced, it was no more efficient to expand the capacity from K1 to K2, less should have been planned. So the overall welfare, if we take into account the benefit from expansion of the transmission capacity and the benefit on market 2 in this case, due to the expansion of generation capacity, it is reduced, even without including the CRM costs themselves. It's just that some of the welfare gain due to the expansion of transmission capacity have been crowded out by the expansion of generation capacity in market 2, because in this case, generation capacity and transmission capacity are substitutes. We can also describe a situation like this in which they are perfect substitutes. You could have efficiency by expanding transmission capacity from K1 to K2, or you could have efficiency by expanding the generation capacity in market 2 with no expansion at all of transmission capacity. So if a CRM is to be implemented in market 2 in an uncoordinated way with market 1, no transmission expansion should be set up. Or if a transmission expansion has to be set up, no CRM should be implemented. We need to take into account when designing CRM's market that there is an interplay with transmission capacity, and the two have to be designed at the same way, together. Otherwise, inefficiency arises. Okay, let's go on. The third element is the impact on security of supply, in particular the need to provide security supply assessment, and the possible the possible interaction with the market integration. Let me make an example. Let me make the example of the European Union. In the European Union, remember that there is a need to enhance cross-border participation, to improve security of supply. For instance, I should mention that there is a target of reaching a 10% average interconnection capacity across member states. At present, it is at 8%, and the new strategy of security of supply sees an increase, a further increase towards the 15% target. We also have a very uneven situation in which some markets are extremely highly integrated among themselves. For some, the interconnection capacity is very limited. But there are two pillars of electricity security supply in Europe. And remember, CRMs are tools that should be designed to address issues of security supply if there are such an issue. So what can we say about the security supply? Well, typically there are two approaches. Typically that we have to follow. The European approach is that has to be coherent with the overall target of the European market integration, and in particular with the guidelines on state aid on energy and environmental state aid guidelines. The basic principle on security supply in Europe is that security supply is a member state obligation, but this should not interfere with the process of the completion of the internal energy market. It is even explicitly mentioned in the environmental energy state aid guidelines that when you think about introducing a CRM, a tool to remunerate capacity, you have to take into account also the CRM in a holistic way with all the other aspects that are relevant for energy markets. In particular, you should assess whether it is transmission, interconnection capacity that could remedy any problem of generation adequacy rather than CRM. In particular, as I said, when you set up, when a market, when a country has decided to introduce a CRM, this design should be such as that external participation to the CRM has to be able. External participation means that those who could provide capacity to the given market, even if they are located outside the market, have to be able to participate, provided this is physically possible. And when I say those who provide physical capacity, I do not refer just to generation capacity, because if you think about a market, and the market has interconnections, and think about a power plant that is located outside that market. Let's make an example, for instance. The Italian market, North Zone, and there is a power plant in France. There will be two elements to be taken into account for the power plant in France to participate to the Italian CRM. The first element is the fact that the power plant is located in France. The second element is the fact that energy generated in France can be transmitted to Italy through the interconnectors. So there are two elements to be taken into account: the generation capacity and the existence of the interconnector. And all market designs that one might want to implement have to be made coherent at the European level, where coherent means that they should be designed so as to avoid negative effects, negative impacts on the internal market. How is the situation in Europe? We have already seen it last slide, so let me be very quick on this. It's really a patchwork of very different schemes. The reason are the two principles that are the main principle of, I would say, European participation, or participation of member states to the European Union. Precautionary principle and subsidiary principle. Applied to energy, the precautionary principle means that it is legitimate to assume, on the basis of the precautionary principle, that the market price signals alone does not deliver sufficient capacity to meet future demands. And the subsidiary principle, the fact that given the security supply is a member state obligation, whatever is in that member state has to be taken into account to provide security. Whatever is outside the member state might not be taken into account to provide security. In particular, the role of the interconnectors, the contribution interconnectors. Again, I want to be very clear. I'm not saying that these two principles, precautionary principle and subsidiary principle, are sufficient to induce a member state or a country to implement a CRM. I'm just saying that because of the application of these two principles, in case by case, CRMs are being implemented in Europe in different ways, and this has to be made coherent with the European framework, and as a consequence, there will be to be a scrutiny from the European Commission, for instance, to see to what extent they are coherent with the state aid guidelines on energy. This is like we already see, very different patchwork throughout Europe in a system that is more or less interconnected. Let me skip it quickly. The problem is that at present, no CRM allows explicit cross-border participation. I should say, to be extremely precise, that the actual Irish scheme allows the interconnector with the UK to participate, but in any case, even in Ireland, they are thinking about changing the scheme. There are basically just three exceptions. The new schemes that will be implemented in Italy, where we are going to implement system reliability options that will explicitly allow for external participation once the technical feasibility is assessed. In France, where a system of capacity obligation, is in place, and they are assessing how to allow external capacity to participate in the capacity obligation scheme. And in Great Britain, which is at present the only system in which there will be an explicit participation to the capacity auction scheme in Great Britain of external capacities. We will discuss at the end of the presentation, if you like, how this scheme will apply. Why is it important to discuss? Because there are several ways in which external capacity could participate to CRMs. And again, remember, the call for external participation is required by the state aid guidelines in the sense that a system has to show, a scheme has to show why is it that such a requirement has not been fulfilled, for instance, because of technical difficulties or whatever. This is the principle of the European scrutiny, that it does not design, there is no design of single scheme that has to be applied, but any market design has to be checked against the European rules, and in particular to whether it is it could harm European integration on the one hand and the completion of the internal energy market. For energy, this means, for instance, it has to be checked against the requirements we have already seen, whether the scheme is allowed external participation or not, and if not, why. But more in general, how the scheme has been designed, why it has been implemented, and what are the expected pro and cons, basically. Several dimensions of cross-border capacity. We can discuss about cross-border participation in the capacity markets. We can discuss about the type of products, availability or delivery. I will make it clear in a second. The type of remuneration for this capacity, external capacity that is about to participate, whether it is explicit or implicit. And then there are different models in which this participation can effectively take place. Three models: interconnector model, direct participation, or revenue sharing model. Let us review all these three. Okay? Availability versus delivery. Availability, let's first define what availability and delivery is. Availability means the capacity is remunerated just for the fact that it is available, that it makes itself available at the time in which it's needed. Delivery means that the capacity is remunerated because it delivers the energy at the time in which it is needed. Now, this difference can be subtle, but let me make an example that can make it extremely clear. Sorry, just a second. Think, for instance, for the case of reliability options. Availability means that at the time in which you are needed, the power plant that had sold the option to the TSO, when it is needed, it makes itself available. How? By bidding into the market. Whether it is dispatched or not is not an issue. So whether it effectively provides energy or not to the market depends on the dispatchment. Dispatching, which depends on the economic principles, we know. Delivery means you are remunerated only if when you're called you effectively deliver energy. Okay? Now, from the standpoint of view of Europe, of the European integration, we have to take into account how European integration rules for energy and for electricity in particular are, how they are and how they are evolving. In particular, there are some references, the framework guideline network codes processes, which induce a further integration of electricity market, and for what it matters here as a relevant one is the cross-border capacity allocation network code that defines the way transmission capacity has to be allocated in an efficient way across Europe. And also the process of market coupling, the integration of wholesale markets, basically, through an implementation of single market clearing price rules and implicit participation to wholesale auctions, in the sense that it is the clearing price of the auction in different markets that define whether energy in one market is exporting or exporting to the other one, on the basis of the price differentials. But the consequence of these two principles imply that there cannot be a cross-border capacity reservation ex ante for a very long time scale. Capacity has to be divested to the market as close to the real time as possible. It will be energy markets that it will be, so wholesale markets or real time or intraday or even balancing that will deliver the proper price signals at the time of system stress. And this implies that the availability model, a system in which capacity is remunerated just for the fact of being available, is to be preferred to a delivery model. However, there is an issue that is still an issue that has to be resolved, is how to update the market coupling, for instance, when you have simultaneous system stress in interconnected markets. Because in that case, there will be no proper market signals to deliver energy where it is needed, given that it is needed in both markets. Type of remuneration. What is that we mean when we describe the different type of remuneration of CRMs? Implicit remuneration of external participation to CRM or explicit remuneration of external participation to CRMs? Implicit cross-border participation basically means that the capacity located outside the market is implicitly taken into account. What do I mean implicitly taken into account? I mean that its contribution through the interconnection transmission capacity is taken into account when the capacity need is assessed. So it is a contribution that is taken into account in the security supply assessment, at the security supply assessment level, not at the level of capacity remuneration. Explicitly means that the capacity remunerated outside is explicitly remunerated, receives a remuneration for being available, if it is for availability, or for delivering energy, if it is for delivery. Let me make an example that should make this issue extremely clear. Suppose that you have a market in which there will be some offer of capacity and some demand of capacity. Let's have a look at this market on the very left-hand side of this picture. As a consequence, you see this market would have a market clearing price of capacity euro per megawatt. Like we said, price of capacity is for megawatt, not for megawatt hour. What does implicit participation mean? It means that when a TSO, for instance, the one who is responsible for security supply, assess the need of capacity, this was the need of capacity assessed, in this case, this is a quantity-based tool because a quantity has been set up and the market determines the price. Well, okay, when this quantity is assessed, the participation of external capacity through interconnector is implicitly taken into account. It reduces the demand of capacity. What does explicit participation mean? It means that the explicit participation, so the offers of capacities in an auction, for instance, is increased by the offer of capacity of that capacity is placed externally to the market. So explicit participation means increase of supply of capacity. Implicit participation means reduction of demand of capacity, basically. Of capacity, again, remember, capacity is not energy. Main difference between the two? Well, obviously, implicit participation basically means that you take into account the contribution of external capacity in security supply assessment, but then there is a possible issue of risk in the sense that at the point of system stress, that capacity might not be there effectively available. So there is an issue of risk which is borne by consumers in implicit model. In the explicit model, on the other hand, you explicitly remunerate that capacity, but that capacity might be remunerated. For instance, think about it is remunerated but on the basis of their availability, but they are not available at the time of system stress for reasons not due to their fault. We will review this. For instance, if it's a power plant located outside, it would be available, but there is not enough interconnection capacity. Or if it is in the connector, the interconnector has not enough generation capacity to provide energy. So the risk of not being available somehow is attributed to the participants, to the market, to the explicit, those who receive explicit remuneration. Again, I repeat, there is an issue of risk. When it's implicit remuneration, risk is attributed to consumers in the market at CRM. When it is explicit, the risk is switched to those who participate from outside. There is an issue of long-run incentives, because obviously implicit participation basically means that external participants don't receive a remuneration. So there is less incentive to provide that generation capacity. While if there is explicit remuneration, they explicitly receive a remuneration. And there is an issue of discrimination in the sense that with implicit participation, external participants are not remunerated, while with external explicit participation, they are remunerated. So if that's exactly the same capacity, they are just discriminated by being physically located in a market or not. This might be regarded as discrimination, as discriminatory procedure. And discrimination is not allowed in the European Union, basically. Three possible models of external participation. The question behind this three model is, how does effectively a capacity, for instance, think about a generator located outside a market, a generator in France, how can he effectively participate to the Italian reliability option scheme? As we said, the issue is shifting risk to these different operators. And in particular, there is one further layer of complexity for a capacity located in Italy to participate in the Italian reliability option scheme, for instance, the capacity has to be located in Italy. But this is already guaranteed by the fact that it is in Italy. So it will have to have some specific features according to which it can be interconnected, it can be connected to the grid, etc., etc. The same has to apply for the capacity located in France. But there is one further difficulty for a capacity located in France, the fact that in order to be available for the Italian provision of energy when it is needed, so in order to be considered available to provide security supply in Italy, it has to be located in France, so it has to respect the conditions according to which it can exist and be interconnected to the grid. But the French grid has to be interconnected with the Italian one. So there are two elements to be taken into account, the interconnector and the generation capacity in France. These are the two operators according to which the different models of participation switch the incentive and the risk between them. An interconnector model. There is interconnection between a market and another market. The interconnector participates to the CRM. Again, an example. In Italy, the interconnector with France participates to the Italian market. It is the interconnector who receives the remuneration for the capacity, if it participates to the market. It is the interconnector who bears the risk of being available or not. Direct participation. Power plants located in France participate to the Italian market. It is their obligation, their right and duty to be available. Hello? Yes, a third system is the revenue sharing model. Revenue sharing means it's an hybrid model in which let me say it this way, both interconnector and capacities and generation capacity participate to the external market. This can be done in two ways. For instance, suppose that there is an auction in Italy, the interconnector participates, and then it is awarded some quantity. This quantity is converted into another auction that is reserved for the French capacity, for instance. So there is a second auction for the quantity for which those external participants can, thanks to which those external participants can participate to the Italian market. It's a kind of a quota system somehow. This quota system is distributed, the interconnector gains this quota and then it distributes it to external participants through an auction. Or there can be a price splitting in the sense that external participate, French power plants participate to the Italian market, they will receive a remuneration. If this remuneration is different, for instance, is lower than the remuneration of the Italian participants to the Italian market, this price differential is attributed to the interconnector, because it is the interconnector that effectively makes able the French participants to participate to the Italian market, so to say. Okay, let us review quickly the features of these three models and their pros and cons. The interconnector. The interconnector is the one who participates, is the one who receives the remuneration. It is the one has to have the pros and cons of participation to the CRM. It is the pro is that to some extent it is easy to guarantee the participation because interconnectors are already interconnected to a market, so they are already known, so to say. They exist, they are there. But the crucial element here is that you have to assess the quantity thanks to which the interconnector can participate. And we know that the nominal quantity of interconnection is not the quantity that is effectively released to the market. So the quantity of the connection capacity has to be derated at the level in which it is regarded as sufficiently stable, namely sufficiently available in real time. The good is that when interconnector has scarce resource, they are the one who are remunerated, so they are the one who receive the incentives to be more available. So there will be a CRM that can solve one of the problems we saw at the beginning, providing remuneration to transmission capacity rather than generation capacity. Foreign direct participation is vice versa. When they are the one who, the foreign generators participate, they are the one who have to make themselves reliable and responsible, sufficiently reliable to provide, to be available for the Italian market, for instance, if they are in France. When it's the foreign capacity, the scarce resource, they are the one who receive the incentives. The revenue sharing is a system that, if you think about it, does not require ex ante to decide whether it is interconnection, the limited resource, or generation capacity, the external generation capacity, the limited resource. Think, for instance, about the auction systems. If interconnector has a lot of value for for a given CRM, because it's very scarce, you can expect it to receive a very high capacity premium by participating in the auction in the market that remunerates capacity. And then it turns its back and opens the auction to the foreign capacity locators. Again, Interconnector with Italy receives a high remuneration, then it sets up an auction for French generators that wants to participate. If they are extremely available, the French generators are not the scarce resource, they will compete a lot among themselves. You can expect the clearing price of that auction, the one reserved for instance, to the French generators, to be a very low clearing price. So there will be a high difference between the price that the interconnector has gained when it has participated in the Italian CRM auction, and the price that the interconnector has to pay to the French capacity when it relieves the amount of interconnection capacity that it has won in the Italian auction to the French market. So it will be endogenously determined which one is the scarce resource. If the scarce resource interconnector is the one who receives the highest part, the highest share of remuneration, if, or vice versa, is not the interconnector the scarce resource, or if it is relatively more scarce the generation capacity than the interconnector, it will be the generation capacity located outside that receives the highest share. The problem of this system is that it adds a further layer of complexity. So you just not, from the standpoint of regulator, for instance, it has to set up the rules to internal participation in a CRM, and then it has also to set up rules for external participation and monitoring the implementation of those rules. If there is a new auction, for instance, it has to monitor also that auction. If there is the ticket system, it has to monitor effectively how the price is shared. So it adds a further layer of complexity to a system that is already complex. Okay. There are, even if this is the case, even if we can foresee these three different schemes that, thanks to which participants can participate to CRMs, there are still open questions, open problems that have to be solved. The first problem is that how much should be external participation? We have seen that implicit participation is just another way of calling contribution of external sources to security supply. Explicit participation is explicit remuneration, but still you have to assess what is the contribution to the security supply of this external participation. So a prerequisite to allow external participation to a CRM is to assess security of supply. But if security of supply is not just a local element because the system is interconnected with other systems, you have to assess security of supply at the level in which these interconnections exist. So at least at a regional level, there has to be a regional assessment of security supply. And how does this has to effectively take place? How efficiently this could be done? It's a crucial element that still is an issue that is studied. It's going to be studied at least. A couple questions coupled with this one is the fact that you have to assess how much is the interconnector capacity effectively available at the time of system stress. So what is the effective amount of capacity that can be regarded firm and it is effectively there at the time of system stress? And how can you make sure that, for instance, the S.O.S don't cut that capacity at the time in which you have an internal system stress? It's another open question that has to be tackled. Proper assessing the amount of interconnection capacity and making it firmly available for the market. Another open question is multiple participation of capacity. Think, for instance, in terms of the explicit participation scheme. A generator can participate to an external CRM. But to which CRM? If there is a country that is connected with other 5 or 6 countries, and in each of these 5 or 6 countries there are CRMs, can it participate to 5, 6, 7 CRMs? Can a generator in France participate to a CRM in Poland, or a generator in Poland to a CRM in Spain, given that effectively they are interconnected, even though they are not directly interconnected? That's another question, which is the corollary of the multiple participation. Again, there are answers that could be yes or no, because they basically imply different risk, different pro, and different consequences. Basically, we can say that to the extent that you can ex ante foresee that system stress are not going to be joint, this could be allowed. But if the likelihood of having joint system stress increases, the more the likelihood of having joint system stress increases, the more is the inefficiency of simultaneous participation, because effectively that capacity cannot be simultaneously be available when more than one system stress occurs. How can you implement this constraint? It's another big issue. Another issue is providing same level playing fields for the capacity. We are discussing capacity as if there was a single common definition of capacity, but that's not the case. There are several different definitions of capacity. So how can you make sure that the same definition applies to all? And last 2 questions that are very relevant, for instance, is about demand-side participation. All these presentations somehow was easily, or more easily, let me say, understood if you have in mind that external participation is about a generator, or that in general the participation to a CRM is about a generator participating to CRM. It is already not too easy to allow demand-side participation in an internal CRM, but it's even more complex to allow demand-side participation of external sources to a CRM. Can it participate? How? And last but not least, this presentation was set up so that a CRM was a theoretical concept, but last presentation I insisted very much on saying that different CRMs have different features. So are there specific features of CRMs that makes more or less easy or more or less difficult to allow for external participations? The first element, for instance, that comes up to my mind that is striking is strategic reserves. Strategic reserves are taken out of the market. Can there be an external participation to a strategic reserve scheme? For instance, if Germany is about to implement strategic reserves, which is the case, by the way, could a capacity in France participate to the German strategic reserve scheme? And if so, how? How can you make sure that that reserve is taken out of the market from France and being available only for the German market at the time in which it is needed? It's another big question that has to be solved. I am done, and I am open to questions now.